Ever stop and wonder how engineers manage to cram millions, or heck, even billions of tiny components into a single gadget and it just works?
Well, today we're diving into the hidden art that makes all of our modern tech even possible. I mean, think about it. The smartphone in your hand, the dashboard in your car. We're just surrounded by this incredible electronic complexity. And these things really are miracles, right? Miracles of making things tiny and keeping them all organized.
But here's the thing. The very first blueprint for these devices, what we call the electronic schematic, it often starts out as a total rat's nest. And I mean, just picture a completely tangled, confusing web of wires and connections. It's almost impossible to follow. For an engineer, this is pure, unfiltered chaos. So, that brings us to the big question, right? The central challenge for any electronics designer. How in the world do you take that digital spaghetti and turn it into something elegant? Something you can actually understand, and, something that works. Let's get into the brilliant techniques they use to pull it off.
Okay, first things first, we've got to tame those wires.
So the very first tool in the toolbox is something called a net label. Think of it this way. Instead of drawing a long, messy wire that winds all over the page, an engineer just gives a connection point a name. Let's say data_out. Then, somewhere else on that same page, they create another point and give it the exact same label. The software is smart enough to know, hey, these two are connected. It's like an invisible wire, and boom, the page is instantly cleaner.
And this one simple change, it's a game changer. The schematic gets way cleaner, it's so much easier to trace where a signal is going, and you're much less likely to make a mistake when you're drawing it. Plus, if you need to change something later or fix a bug, so much easier. It's definitely the most basic form of organization, but it is absolutely essential.
So net labels are fantastic for a single page. But let's be real, modern projects, we're talking a whole computer, a complex sensor system, they are way, way too big for one sheet of paper. So what do you do then?
Well, for these huge projects, engineers actually borrow a page from architecture. You'd never build a skyscraper with one giant, messy blueprint, right? Of course not. You'd have separate plans for the electrical, the plumbing, the foundation. Electronics get broken down the exact same way, by what they do, by their function.
This is what we call a hierarchical approach, and it's super logical when you think about it. First, you divide the whole project into its main functional blocks. The power supply goes here, the main CPU here, the display driver over there. Each of those gets its own schematic sheet, its own little blueprint. Then, you create a top-level page that's basically a master map, showing how all those smaller blueprints connect to each other.
And this gives us a blueprint for complexity, which means we need some smart ways to organize all these pages.
So, there are a couple of ways to do this. One is a flat hierarchy, where all the pages are kind of peers. They're connected by global labels that can jump a signal across any page in the whole project. The problem? You don't get a big picture view. On the other hand, you've got a simple hierarchy, which gives you that bird's eye view. The top-level page shows each circuit as a nice, neat block, and the signals pass between them through these official doorways called hierarchical pins. It lets you see the whole system's architecture in one glance.
And to make those high-level diagrams even cleaner, engineers have another trick up their sleeve, the bus connection. Okay, so if you have a whole group of related signals, like say the 8, 16, or even 32 wires that make up a data bus, you can bundle them all together into a single, thicker line on the schematic. It's like taking a dozen little back roads and turning them into one big superhighway. It just massively cuts down on the clutter.
Okay, so we've organized our design into these nice functional blocks. But what happens if some of those blocks are actually identical? I mean, what if your design needs to use the exact same circuit over and over again?
A stereo amplifier is the perfect example here. You've got a left audio channel and a right audio channel. Now electrically, those two circuits are 100% identical. Would you really want to sit there and draw that whole complex circuit twice, part by part? No way. That's super inefficient and just asking for a mistake.
And this is where we get to a really powerful idea. Design once, use everywhere. This is done using something called a complex hierarchy.
Here's how it works, and it's pretty slick. You design that amplifier circuit just one time. You save it as its own file. Then, back on your main schematic, you create two empty blocks. You label one left channel, the other right channel. And here's the magic trick. You link both of those blocks back to that same single design file. You've just made two separate copies from one master blueprint.
This approach is a total superpower. First off, it saves a massive amount of drawing time. It also guarantees that your identical circuits are truly 100% identical. And the best part? If you find a way to improve the circuit, you just change that one master file and every single copy updates automatically. It's a huge deal for managing massive projects.
And why do these techniques matter so much? Because the scale we're working at today is almost mind-boggling. I mean, a single high-end processor can have over 50 billion transistors. Trying to manage that complexity without these strategies, it would be physically impossible. Period.
So, let's just recap the journey from chaos to clarity. We started with net labels just to clean up a single page. Then we used simple hierarchy to organize a bunch of different pages. And finally, we unleashed the power of complex hierarchy. That whole design once, use everywhere idea.
You see, these methods aren't just about making schematics look pretty. They are the invisible language of electronic design, the grammar, the syntax. This is the fundamental logic that empowers engineers to build the unbelievably complex technological world we all live in.
And that transformation from a tangled web of wires into an elegant, manageable, and reusable blueprint, that really is the hidden art form behind every single piece of technology you own.
So, the next time you use any of your gadgets, just take a second and think about it. What incredible, unseen order, what elegant blueprint is hiding just under the surface, making it all possible.